If you spend any time in automotive circles online, you have likely seen a persistent rumor aggressively overtaking the conversation, an incoming crazy mutation in gasoline engines, slated for 2026, that will permanently derail the electric vehicle market. Like most internet panics, this one stems from a real academic document. This is the research summary that sparked the rumor, complete with the headline citing a crazy mutation arriving in 2026. Looking past the headline to the actual text, the researchers explicitly frame these 2024 to 2026 innovations as a means to maximize efficiency and cut emissions. They note that while this extends the relevance of combustion, electric vehicles remain essential for meeting long-term climate targets. To understand why this engine upgrade is actually significant and why technical data sparked such extreme rumors, we first have to look at a severe mechanical flaw that has choked the combustion engine for over a century. Internal combustion relies entirely on breathing. To generate power, an engine must constantly open intake valves to pull fresh air in and open exhaust valves to push burned gases out. Historically, these valves are forced open by a spinning metal rod called a camshaft. This rod is locked directly to the bottom of the engine by a rigid chain or belt. Because the top of the engine is physically chained to the bottom, the timing of those valves is permanent. Engineers have to shape the camshaft to breathe reasonably well at highway speeds and reasonably well in stop-and-go traffic, but it can never be perfect at both. For 100 years, every gas-powered car has suffered from this identical constraint. They are literally trapped by their own rigid mechanics, unable to adjust their breathing rhythm to actual driving conditions. The solution to this century-old bottleneck is to throw the metal camshaft in the trash and sever the mechanical link entirely. This brings us to the real innovation the research paper is tracking: electro-pneumatic variable valve actuation, better known as the Camless engine. Here is how it operates. The heavy camshaft is removed entirely. Instead, an independent, computer-controlled actuator sits above every valve. A digital brain tells each valve when to open, how wide, and when to shut, using a fraction of the energy of a spinning shaft. By digitally decoupling the valves, the engine breathes perfectly in every single operational scenario, adapting millisecond by millisecond. This electronic control allows the engine to customize its valve lift profiles instantly, maintaining optimal breathing even when the engine is spinning at 5,500 RPM. We can measure the exact impact of this decoupling by looking at the 2024 engineering literature. Researchers ran optimization models and mathematical tests on high-frequency electro-pneumatic actuators to see what the hardware could yield. This source document notes their most striking data point. By using genetic algorithms to optimize the valve timing, volumetric efficiency increased by 63% over a conventional cam mechanism. That high-precision airflow triggers a chain of secondary benefits. It stops the engine from fighting its own internal air pressure, which reduces pumping losses and naturally drives down exhaust temperatures. Gaining 63% in volumetric efficiency represents a massive mechanical leap. When technical gains are this significant, they are often reframed by headlines as a sign that gasoline has finally overtaken electric power, ignoring the specific applications the researchers were actually studying. So we arrive at the final reality check. Does this massive efficiency boost actually make gasoline engines carbon neutral or eliminate the need for electric cars? The data suggests otherwise. Burning fuel inherently produces carbon, meaning long-term emission goals still rely on broad electrification. Engineers developing this tech target markets far from the highway, designing systems for marine vessels, heavy machinery, and extreme off-road applications. In these specific sectors, full electrification is currently restricted by the laws of physics. You cannot attach enough heavy lithium-ion batteries to a commercial cargo ship to cross an ocean without the weight of the batteries sinking the vessel. For daily commuters, electric vehicles remain the primary path to zero emissions. Camless technology finds its value in heavy industry, acting as the final mechanical refinement for environments where we must still burn fuel.